Lab number 6, Projectile Motion by Edgar Herrera.
And Tanya Linares.
In the question given, goats are clearing a 4-meter wide crevice to land at the same height of the cliff on the opposite side, and goats are jumping at the angle of 30 degrees to the horizontal.
The information that we are able to pull for the problem is distance times displacement of x being 4 meters and the angle in which the goats are jumping at being 30 degrees. Also, we know that gravity is 9.81 meters per second squared, and positive being in the up direction and the displacement in the horizontal is 0, as well as all the goats' mass and height being the same. The unknown variables are time, initial horizontal velocity, and the initial vertical velocity. Initial velocity and the height of the goats at the peak of the jump.
The first thing we do is look at the variables we have and see what we can solve for. In this case, solving for initial velocity is a good place to start since we have 3 variables and 1 unknown. We can use the range formula to manipulate to solve for initial velocity. Range being 4 meters, VO being the unknown we're trying to solve for, theta equaling 30 degrees, and G equaling 9.81 meters per second squared. The initial velocity comes out to be 6.73 meters per second. Now, since we have the initial velocity and theta being 30, we are able to solve for the horizontal and vertical initial velocity. Vox equals 6.73 meters per second multiplied by cosine 30 to give us 5.83 meters per second. And solving for Voy is 6.73 meters per second multiplied by sine 30 to give us 3.37 meters per second. Now, by knowing those two variables, we were able to plug in the unknown in the equation to help us progress. We were able to solve for time t using the equation delta x is equal to initial horizontal velocity multiplied by time. By rearranging the equation, we're able to solve for t since we have initial horizontal velocity and delta x, giving us a time of 0.69 seconds.
Now we have to solve for time it takes for the goats to reach the peak height of the jump. Using the equation Vy equals Voy plus G times t, by setting Voy to equal 0 since velocity decreases when it reaches the peak and equals 0 when it reaches the peak. And we know the two other variables and are able to plug it into solve for time. Vy equals 3.37 meters per second equals 0 plus 9.81 meters per second squared multiplied by the unknown t. By rearranging the equation, we solve for t and get 0.34 seconds to reach the peak. Now we are able to solve for y max using the equation delta y equals Voy multiplied by time minus acceleration multiplied by time squared divided by 2. Our y max is 0.57 meters. The minimal launch speed the goats need to have to ensure safe landing 6.73 meters per second. The maximum height the goats reach 0.57 meters. The time in the air 0.69 seconds.